Hello wonderful person, this is Anton and welcome to your planet. This is our home planet Earth. In this video I wanted to answer a relatively simple question. Is Earth losing or gaining mass? Let's do a little bit of analysis and find out what's happening here on this planet. Welcome to What the Math. Now you might already have a certain understanding of what actually happens to our planet and how it might either lose or gain mass. Obviously, people are familiar with things like, for example, asteroids that might actually crash onto our planet and deliver a certain amount of mass. And some people might also be familiar with the fact that our atmosphere is not really constant. It's kind of always either being replenished or lost to space. But what exactly is happening here and how much mass do we either gain or lose? Alright, well let's start with some more obvious things. Asteroids and space dust. Specifically, of course, things like cosmic dust, cosmic meteors, comets, and so on and so forth. If you were to add all of this mass together, how much would you really get? Well, this is actually the most significant contributor to Earth's increase in mass, and overall Earth gets around 45 tons of material every single year. If you were to basically create a tiny rock made up of all of this annual dust, this is what you would get. This is about 45 million kilograms, or basically a rock that's about 15 meters in radius. Now this is on average, and this is of course including some more major collisions that might occur once in a while, but for now this is what we think happens here. Every year we get about this much. On the other hand, every single year our planet also loses atmosphere. As a matter of fact, because there are some gases here that are actually really light, they escape into the outer atmosphere and they kind of go into their merry adventure across space. Specifically, these two gases that we lose a lot are hydrogen and helium. We lose about 1,600 tons of helium, which is this tiny rock that's about 4.9 meters in radius, a little bit smaller than the dust bowl we created earlier. And then we also lose about 95,000 tons of hydrogen, which is actually a rock that's about 19.2 meters. So as you can see, this is the biggest rock so far. In other words, we actually lose quite a lot of hydrogen every single year because it just escapes into the atmosphere. If you actually did the math, you would find out that that's about 3 kilograms of hydrogen every single second. And so if you do the calculations here and basically subtract these two from dust, what you'll get is roughly about 50,000 or maybe 55,000 tons of material. And this is loss of material. So in other words, our planet actually does lose mass overall every single second, every single year. The amount of material lost is roughly equivalent to this dust bowl here as well, because basically we lose about twice as much stuff as we gain from space. Now, there are actually other ways the planet both loses and gains materials, but they're just very insignificant. For example, currently, and for the past 4.5 billion years, our planet has actually been using up some of its mass, specifically on the inside, to produce energy. There are actually a lot of radioactive materials on the inside of our planet that are decomposing due to nuclear fission and are creating energy that basically heats up the inside of our planet. And so there is a little bit of material lost inside the core of our planet as it decomposes and creates energy, but only about 16 tons per year, which is actually significantly less than what we lose through atmospheric loss, and specifically about 100 times less than helium loss. Also, because with time our planet is actually slowing down in terms of rotation, it's losing some rotational kinetic energy. And due to this deceleration, it pretty much loses about 16 tons of mass every year as well. It's not a lot, but just as much as we lose due to the energy from nuclear fission. At the same time, interestingly, according to recent calculations, we also gain about 160 tons of mass every single year in the last 50 years or so due to changes in temperature and specifically global warming. This is something that most people don't realize, but our planet is actually gaining mass because of the global warming. And it's actually about 10 times higher than the mass loss due to nuclear fission on the inside. And lastly, the most interesting way we actually lose mass is also human-made. And this is actually due to spacecraft and various rockets that were launched in the last 53 or so years of space age. It's actually estimated that approximately 65 tons per year were lost by essentially launching these rockets. And this actually equates to a total mass of about 3.4 million kilograms, which is basically a rock that's about this big, about 7 meters in radius. Now, obviously this is not as big as some of the rockets. As a matter of fact, if I were to place the third stage of Saturn V rocket, you would see that it's sort of comparable in size. So how is that possible? Well, don't forget, there's a lot of empty space on the inside here. And also, a lot of these parts actually did come back to Earth after a while. But in terms of the actual loss of all of the stuff that we lost through rocket launches, it's about 3.5 million kilograms. And so this right here represents the total lost mass every single year. But this also means that if you look at billions of years, maybe this mass will become significant. But turns out that even if you consider the age of our planet and multiply this mass by essentially 4.5 billion years, you're not really going to get that big of a rock. And so over a period of 4.5 billion years, hypothetically, this is what you would lose. This is a rock that's about 25 kilometers in radius, which is equivalent to a relatively large asteroid. But in comparison to our planet Earth, it's actually super tiny. As a matter of fact, it is really tiny. It's almost nothing. It's insignificant. Every single year, we lose a fraction of a percent of mass. It doesn't really even affect our planet almost at all. It would actually take trillions of years for all of the hydrogen on our planet to be depleted if we lose it at this rate. So it's not really that big of a problem. Unless, of course, our planet loses its magnetic field. The magnetosphere does protect us from more loss, and so finding ways to maintain it and to possibly protect it in the future is really important. And so let's finish the simulation imagining what would happen if all of this lost mass, specifically hydrogen and helium, actually came back to our planet after 4.5 billion years and decided to collide with it. This is a rock that's about 25 kilometers in radius, and it's going to leave quite a mark on our planet. Here we go. Anyway, thank you for watching. I'll see you guys tomorrow. Come back tomorrow to learn something else, and subscribe if you still haven't. Share this video with someone who enjoys learning about space and wants to learn through video games, and maybe even consider supporting this channel on Patreon. Space out, and as always, bye bye.